So this sort of brings us to the end of the seminar itself. So we've covered an awful lot actually in really quite a small space of time, giving you a little bit about the background to sound, looking about how sound is controlled using absorption, which provides a good environment to work in, sound insulation, which stops disturbance or stops something disturbing somebody else, about covering the sound or blocking the sound using background noise, and diffusion. And that actually fits quite nicely into A, B, C, D. Absorb, block, cover, and diffuse. We'll be more than happy to take your questions now on anything that's come out of this, and hopefully you've had a chance to put those through to Robert now. So if I can hand you back to Robert and ask for any questions.
Thank you very much, Joe, for a very informative presentation. I do have a few questions for you. If I could start, first question is, why do double glazed walls have two different thicknesses of glass?
That's a great question. It's to cut down a thing called sympathetic resonation. And a good example of that, if any of you have been to see a band lately, and you will see the bass drummer sitting in the middle of the band, and he'll be thumping away like this. And as he's thumping away like this, bringing out the beat, you'll notice that the skin on the front is moving. It physically moves. But yet there's a big chunk of air between the two skins. And that's because the frequency at which the first skin is vibrating is being matched by the thickness of the skin on the front. They're both exactly the same, so they will reverberate sympathetically. If you use two different thicknesses, two different densities, you cut down on that sympathetic resonation. So that's why you will have a 10.8 and a 12 or something like that to reduce that and increase the sound insulation between the two rooms.
Right, thank you very much, Joe. Another question for you. How do sound attenuators work?
How do sound attenuators work? They work in a similar way to a silencer on a car. So they still allow the exhaust gases to go through, but they get the exhaust gases to go through a series of curves and dead ends before the exhaust gas actually comes out. So the energy that started with the initial ignition of the car has been dissipated through those curves and turns and absorbent material around the bulk of the silencer. So they're working a similar way to that.
Thank you very much, Joe. A few more questions for you. Is it possible to achieve a dB RW figure on site?
That's a great question. Partitioning is often specified during the process, especially within NBS, as 45 dB RW. The weighted sound reduction index can only ever be achieved in a laboratory. You cannot achieve that through a site test, because a site test will look at all of the areas of flanking around the space, and so what you'll end up there is with a single figure decibel under a DNFW or a DNTW test, and they're site tests looking at the whole of the environment. Broadly, the difference between the two will be somewhere between 5 and 7 or 8 dB. The white book produced by one of the plasterboard manufacturers is a good reference to that. The best that you'll ever achieve is that sort of difference between the two.
Right, thank you, Joe. And just one last question to wrap up the webinar. What effect will a door have on a partition?
What effect will a door have on a partition? It's a hole. You've introduced a hole into this wall that you're looking to reduce airborne sound through. And as soon as you've got a hole, the sound will go through there. So you can close the door, clearly. You can close the door into a rebate. That will make a difference. You can put drop-down threshold seals to sort of seal the door in place, but quite often the performance of the door will be less than the performance of the partition. Typically a partition at 45 with a solid core door, you might get 35, 36, 37. Again, as a test of the product within a laboratory. So there'll always be the difference between the two. The application that I mentioned to you earlier from iTunes is one of the ways that will help you calculate that. An acoustician will have all of the tools available to them to help calculate that. But bring that back with the point that I made about background noise. If you've got two offices side by side, if you seal all of the background noise from coming into that space, you create an artificially quiet space, which will make it very difficult to achieve privacy from room to room. I'll give you an example of how that background noise works as well. If you've ever been in an office late at night, you'll notice it gets quieter and quieter and quieter. And then about whatever time it is, the mechanical air handling units turn themselves off. And you'd forgotten they were there in the first place, and it gets even quieter. And then you can hear somebody 5 offices away shutting a door or talking to somebody. It's because of the background noise has suddenly gone away. And if you create 2 offices side by side with no background noise at all, you will find it harder to achieve privacy from room to room. So my hint is always actually allow some of that background sound to leach in through the door and above the partition. So I hope that's helped, Robert.
Right, thank you very much, Joe. AIS hopes you found this webinar informative, educational and inspiring, and a big thank you to Joe once again. Just before closing this webinar, I'd like to just point out a couple of things. That the presentation will be available as a PDF on the AIS website, www.ais-interiors.org.uk, and within a few days we will have a recording of this webinar available for you to view and listen to. Once again, thank you very much for attending. I'm now going to close the webinar.